Hello and welcome. My name is Richard Stember. I'm the Executive Director of Science Heads and a volunteer with NASA. Today I'm joined by Spencer Murray. Like me, Spence is a chemist and has been an amateur astronomer for many years. He's also a volunteer with the Orange County Astronomers and has participated in literally hundreds of outreach events at local schools, libraries, and other public venues. Our star party tonight is titled Discovering Asteroids and Comets, an Amateur Astronomer's Perspective. It's meant as an introduction to these unique and interesting objects in our solar system. We will discuss how you can view them and maybe even discover some new ones. During this event, you're welcome to enter questions into the GoToWebinar question pane. We will do our best to answer all of them during or after the event. And kids, please let us know what grade you're in. Before we start, I want to tell you a bit about our organization. Science Heads is a 501c3 nonprofit whose mission is to promote and support STEM education. We host educational events at schools and public venues, and we are a member of the NASA Museum Alliance. Our volunteers love science, technology, engineering, and math, and if you do too, I invite you to check out our website at scienceheads.org. Lastly, as I mentioned earlier, the slides that we're using tonight are available in the handouts pane for you to download. They include many useful links to learn about the topic. So with that out of the way, we can get started. Hey, Spence, what exactly are asteroids and comets?
Okay, first of all, Richard, thank you for the introduction and welcome to all of our guests. I thought we'd start off with describing what asteroids are. The description is actually very simple. Asteroids are irregular shaped, rocky, and metallic objects in space. I want to go a little bit into what they are made of. There are three basic types of asteroids. They're called C-type, S-type, and M-type. The C-type stands for chondrite. They are basically made of clay or silicates, rocks, and they are about 75% of the known asteroids. The S-type stands for stony. They have very little clay and they have a lot more rocks, and they will have some instances of metals as well, mostly iron and of nickel. So S-type or stony asteroids are about 20% of the population of asteroids. And then finally, M types are metallic. They are more rare. They're about 5% of what exists. They are basically iron and nickel, and on occasion, they can have other metals, some precious metals. Platinum has been found, and gold is as well. So those are the three different types. I wanted to just take a second to talk about a very interesting asteroid that some of you may have heard about. It's called Psyche, P-S-Y-C-H-E. It's generated a lot of interest for two main reasons. One is it's thought to be solid metal. It's the only asteroid that's been located so far with that designation. The other interesting thing is it's about 140 miles in diameter, so it's very large. Not only is it iron and nickel, but it's been shown to have quantities of platinum and gold and other precious metals. So there are a lot of eyes looking at this asteroid, trying to figure out how to get a piece of the pie. If you calculate based on the composition what that asteroid would be worth, it's estimated it is, you have to listen to this, 10,000 quadrillion dollars. So I know that's a number that's way too big for me to be able to get my arms around, but what that relates to is that amount, those number of dollars would make every person on Earth an instant billionaire. So you can see why there's some interest in it. NASA had originally planned on sending a spacecraft there in 2023. They just recently announced they've moved it up a year to next year. It'll take about 4 years to get there. There'll be some sophisticated instrumentation on there, so we'll get a much better idea of what it's actually made of. You know, the good news is it's probably worth quadrillions of dollars. The bad news is we have no way of doing anything with it. It's too far, but in the future, maybe somebody will figure out how to mine that. So those are the types of asteroids. In terms of size, in general, they range from diameters of about 5 feet up to a diameter of approximately 500 miles. What are asteroids? Asteroids are remnants of objects that were left over when the planets were formed. And let me go into that in a little bit of detail. So you have to remember about 4.6 billion years ago when our solar system was forming, it was a very chaotic place. There were small objects floating around, dust. There were a lot of gases. There were solar winds, and under certain circumstances, in areas those would coalesce, and all those small dust particles would form what would become an asteroid. But it didn't stop there early on. Those asteroids would further agglomerate, and some became big enough to form our planets. And that's what is presumed our planets, how they were developed. So why are these asteroids left over? Well, of course, the behemoth of our solar system is Jupiter. Most of the asteroids are near Jupiter. And it's thought that the huge gravitational field of Jupiter interfered with this agglomeration of asteroids. And so these asteroids are left over after Jupiter was formed. So let's talk about meteoroids for a second. Really, the only difference between asteroids and meteoroids are that meteoroids are small asteroids. So you can see the description is they're still small rocky or metallic objects. The difference is they can be as small as 1/10 of an inch and up to a diameter of 5 feet across, which is when they be called an asteroid. Meteoroids origins can come from asteroids, or, and we'll talk about this a little bit later, or potentially from comets. So you can imagine as these asteroids are flying around in space, on occasion they would bump into each other, and shards of rock would be shed, and those would become smaller asteroids or meteoroids. If you want to get smaller than that, under 1/10 of an inch, objects are classified as appropriately micrometeoroids, and even smaller than that is space dust. So we're not going to talk much about meteors or meteorites tonight, although Richard, you and I have talked that it's a very interesting subject, and maybe that's a subject that we can address at a later webinar. But just real briefly, meteors are asteroids or meteoroids that enter the Earth's atmosphere. And because of their speed, when they enter the atmosphere, they compress the molecules in front of them, they heat up, they shed material, which forms the streak that we see going across the sky. Meteors that are large enough to strike the Earth are called meteorites. Okay, I put together a little trivia fun fact thing here, and I'll go through that. The term asteroid was coined by William Herschel, a renowned British astronomer, in 1802. It means star-like. One of the things I find interesting, of course, is that asteroids are very small, which means they have a very low gravitational field. But there's been over 150 asteroids that have small companion moons orbiting around them. I think that's very interesting. The average distance is more than I think you might imagine. The average distance between asteroids is about 600,000 miles. So on TVs and movies, when spaceships are dodging asteroids left and right, that's really sort of a fictional depiction. They're very, very far apart. In fact, if you take all of the asteroids and condense them into a ball, their total mass would be less than the mass of our moon. It's thought that a very large asteroid was the cause for the extinction of the dinosaurs. and there have been large asteroids that have struck Earth more recently. So we're worried about asteroids striking the Earth. However, now there's not much we can do about it, but what we can do is we can find them and we can identify them and we can track their orbits. So there's a group of asteroids that are considered near Earth asteroids, and those are asteroids that are defined as being within 100 million miles of our sun. And believe it or not, up to this point, there's been greater than 20,000 NEAs that have been discovered, and that number grows pretty significantly every week. There's another classification called PHAs, and those are potentially hazardous asteroids. And those are the ones that we really need to keep our eye on. There's been 5,000 of those found, and their description are they're closer than 5 million miles from Earth, and they are larger than 500 feet in diameter. So that's actually a pretty scary number, and you might think that we should all be running for cover with those asteroids floating around, but somebody calculated the odds of the Earth being struck by a PHA, and it actually turns out that once every century or once every 100 years on average, we would be struck by a PHA.
Well, Spence, thanks for that definition. What then is a comet?
All right. So again, comets the description is very straightforward. They're generally referred to as dirty snowballs. They are composed of mainly ice, particles, and dust, which is where the word dirty comes from, and frozen gases as well. So the core of a comet is actually very small, particularly compared to an asteroid. The cores are only about 1/2 mile to maybe 2 miles across. There are a lot of comets out there. There are greater than 3,000 that have been discovered orbiting the sun. And one characteristic of both asteroids and comets that's different from our planets is that their orbits are elliptical and they're off the ecliptic. And I can explain what that actually means. So in this diagram here, you see, pretend that we're above our solar system looking straight down, and the white circles are the orbits of some of our planets. And you can see the elongated elliptical orbit that would be very typical for a comet or an asteroid. This particular one, Phaethon, is an asteroid, but they have very elongated orbits compared to any of our planets in our solar system. Now, if you take a look from a different angle, rotate about 90 degrees, you can see there's a blue circle there that replicates the orbit of the Earth. So you probably are all aware of the fact that our planets line up in a plane, like I guess you would say a dinner plate, and that's called the ecliptic. So comets and asteroids don't abide by that rule. They come in at an angle, and that's being called being off the ecliptic. So I thought what we do next is talk about what comets are composed of. There's basically 4 separate components. We talked about the ice core, which is called the nucleus, ice and gas with debris and dirt, dust, other solids. Surrounding the comet, and I want to stop here for a second. So in its original state out in our solar system, a comet is not a comet. It's a big, dirty snowball. It's not until it starts approaching the sun that it turns into a comet, and that is because of the increased temperature that it sees. So a coma will start to occur as a comet approaches our sun. It warms up, and around the nucleus is formed a cloud that's made up of water, some gases, carbon dioxide, and other gases that are released from the nucleus. So beyond that, what we normally see, the most visible part of a comet, is called the dust tail. Now, compared to the size of the nucleus itself, the dust tail is huge. It can be up to 3 million miles long. The dust tail is composed of particles that are pushed away from the coma by solar winds. And like I say, these are the tails that we usually associate with comets. Most comets have more than one tail. There's another tail that's much harder to see that's called the ion tail. It can be 10 to 15 times longer than the dust tail. Now, rather than being composed of particles, the ion tail is composed of gases. And those gases light up, they fluoresce because they're exposed to the ultraviolet rays that come from the sunlight. And that's much like fluorescent lights that you see when you plug them in. So that's the ion tail. So let me, on the next slide, there is a description of what all of this looks like as the comet revolves around the sun. On the right-hand side, you can see a picture of the dust tail, the white part, and also the ion tail, the blue part. Now, this is one thing that I find very interesting about comets. If you look at the diagram to the left, and you see that the comet in this diagram is traveling clockwise around the sun. And so as it starts out, both the ion tail and the dust tail are following directly behind the comet, which is what you'd expect. Certainly here on Earth, tails and trails follow behind things. For example, a jet aircraft leaves a contrail. It's always directly behind. But what's interesting is as the comet gets closer to the sun, you can see both the ion tail and the dust tail start to depart from the orbital path. And the closer that the comet gets, the further that departure is. So as you see the comet starting to go around the sun, the ion tail is actually pointed directly at the sun. And this is the case for the entire orbit of the comet. The ion tail is always pointed away. The dust tail, to a certain extent, is, but it also a little bit more closely follows the orbit. So what's interesting is if you follow that path around the orbit, you can see out near the end, the tails, both the ion and the dust tails, are actually ahead of the comet, which I find very interesting.
So Spence, does the tail of a comet make it easier to see?
Absolutely, Richard. We talked briefly about asteroids, which can be very large, but they're mostly made out of rock and other materials that don't have much reflection. And so even a 500-mile diameter asteroid is dark. So they're very, very difficult to see. In contrast, comets, although their cores are very small, have this very large tail that stands out behind them. So yes, absolutely, much more easier to see a comet than it is an asteroid. So I think on the next slide, because we did some trivia on asteroids, I put together some fun facts on comets. So the word comet is Greek for long hair, which makes perfect sense. And I want to talk about the next two bullet points a little bit in detail. So when comets are in their primary orbit and not approaching the sun, they travel actually very slowly, maybe on the order of a couple thousand miles an hour. But something happens to comets that kicks them out of their orbit. And it's been proposed that there's two things that are probable. One is that it gets close to a planet, and the gravitational pull of that planet pulls it out of its normal orbit. The other is that with all of those snowy dirt balls out there, that they can bounce into each other and get pushed out of their initial orbit in any direction. And those that are, excuse me one second. Okay, those that are ejected towards the sun get caught up in its gravitational pull, and the speeds can go from as little as 2,000 miles an hour to, I want to say, 100,000 miles an hour. And coincidentally with that, the temperature of this dirty snowball starts to increase, and it starts shedding some of its components. So the brightness of a comet is very hard to predict, and I think this is very important. It's based on a number of variables. What is the ratio of ice to debris to solid gases? Has it passed through our around our sun before? There's a lot of different things that make it hard to predict. Some comets that are passing through our solar system for the first time actually aren't very tightly bound together, and it's not uncommon for them to break up. So they can be very bright as one ball one day, and the next day it's broken up into maybe a dozen different smaller balls, and you can't see the comet at all. So it's very hard to predict brightness. Just real briefly, meteor showers are the result of the comet debris entering into the Earth's atmosphere. Of course, we know exactly where comets travel. They leave a trail of debris, and it's in the same place every year when the Earth comes around. So it's very easy to predict exactly when the Earth is going to pass through that trail, and that the result of that are meteor showers. Now, two of the best, if you haven't seen a meteor shower, I highly recommend that you go out of your way to do so. The two best meteor showers of the year are generally the Geminid meteor shower, which just passed last December, just about a month ago. The next big one, which is more popular, is in the summertime. I think it's more popular because it's much warmer out. That's the Perseid meteor shower. It can have anywhere from 50 to 100 meteors per hour. It's very impressive. And this year, there's going to be no moon at all. So it's a great year to get out. So if you have your calendars out, mark down the night of August 11th and the morning of August 12th, find yourself a nice dark spot, take a lounge, and just lay down and look up. It's well worth the time. We hear in astronomy, we hear the term naked eye quite a bit. It's obvious what that means. It means that these are objects that you can see without the aid of any instruments at all. So comets, you can't just walk out in your backyard and see a comet. It's not that often that we have naked eye comets. Naked eye comets with bright trails happen about once every decade, about once every 10 years. There's another category that are called fuzzy comets. They don't happen to have tails. They're more often passing by our Earth, but they're also more difficult to see. So, here's an example of two naked eye comets that passed by Earth recently. Some of you may have seen the Neowise comet. It was kind of a surprise, came out of nowhere, got very bright. If you went to a dark sky location, it was very easy to see it. This is an image that was actually taken in an urban area, so there's quite a bit of light. This was just after sunset, I believe, so you can see the nice bright dust tail. A fuzzy comet, it looks just like the image below. They tend to be bluish green in color. There's no tail. This one was called the Lovejoy Comet. It came through, I think, in 2015. This one, I understand, was right on the edge of naked eye, which meant you had to have all the proper conditions. However, this image was taken through a telescope.
So Spence, where do asteroids and comets come from?
Well, Richard, good question. Let's talk about their origins. There are three main areas that asteroids and dirty snowballs exist. The first one is called the main asteroid belt, which is very appropriate. That's where the asteroids are. Next out from that, further away from the sun, is called the Kuiper Belt. The Kuiper Belt is mostly ice balls, comets to be, I guess you would say. And that's the source of what we call short period comets. Those are comets that pass by us and circle around the sun in less than 200 years. Much further out than that is what's called the Oort cloud, and that's the source of long period comets, which don't come around very often at all, greater than 200 years. So the detail on the main asteroid belt is in the next slide. So where is it? So the main asteroid belt is located between Mars and Jupiter. In the image on the right-hand side, you can see the orbits of our planets. The outermost circle is Jupiter. The white fuzzy line in the center is the location of the main asteroid belt. It's described as a circumstellar disk. Well, very simply what that means is that it extends all the way around the sun. It's circumstellar and it's fairly flat. So it's a disk, again, much like a dinner plate. It's located about 300 million miles from the sun, and which is about 3 times farther than is our Earth. So the main asteroid belt is where the rocky objects and the metallic objects live because it's fairly close to the sun and it's no place for a snowy ice ball to exist. So anything that's volatile would have been stripped away from that a long time ago. So there are estimated to be about 1 to 2 million comets that are, asteroids that are larger than half a mile, and many millions that are less than half a mile.
So how is the Kuiper Belt different?
Well, the Kuiper Belt has several differences. First of all, it's located much further out than is the asteroid belt. Remember, we said the asteroid belt is about 3 times further than the Earth. So the Kuiper Belt actually is located beyond the orbit of Neptune. Again, it's described as a circumstellar disk. Now you can see from the diagram below, it's actually a little thicker than the asteroid belt. Maybe you compare it to a donut or a frisbee. So it's a circumstellar disk. It's about 3 to 5 billion miles, or 30 to 50 times farther from the sun than is our Earth. Now this is the home of comets to be, of icy balls. So there are estimated to be over 1 trillion of them, but there are some rocky bodies mixed in with those trillion snowballs. Now I just want to mention that that's a very significant thing to bring up, and we won't get into it in detail, but the Kuiper Belt is actually the home to several dwarf planets. There's been 5 dwarf planets that have been defined so far. Far and away, I think the most famous one is poor Pluto, that was demoted from a planet to a dwarf status. Again, I don't think now's the time to go into that. There's continuing arguments as to what it should be called, but for now it's a dwarf planet, and it exists in the Kuiper Belt. And as I said, the comets that come from there are less than 200 years. The next one, probably the most famous, is Halleys Comet. It orbits every 76 years. Hopefully, most of everybody on this webinar will be around to see it. Mark your calendars. That will happen in 2061. So if we want to go further out, we get to the Oort cloud. Now, the Oort cloud is hypothetical. Nobody's ever seen the Oort cloud. And you also notice in the description, it's not described as a belt. It's a spherical cloud of icy bodies. So the reason that astronomers think it's there is based on the orbits that some comets have and on their orbital angles. So we're talking again about how elliptical their orbits are and how far out of the ecliptic they are. So there's something out there that's spitting out these comets occasionally. So in the diagram below, you can see you can't even see the solar, our planets in the solar system. You can see the frisbee again, which is the Kuiper Belt, and then far beyond that is the Oort cloud. And I'm talking far beyond. So it's approximately 50,000 to 100,000 times farther from the sun than is Earth. It's estimated to be the home of up to 2 trillion icy bodies. And as I mentioned, those are comets that orbit the sun in greater than 200 years. The most famous one of that is probably the Halleys Comet, which orbits approximately every 2,500 years. It was discovered not long ago, which means it's going to be a long time until we see it again. The next time it's going to approach the sun is in 4380. So I think that covers pretty much the description of asteroids, a description of comets, and where they're located. So I think Richard, if I'm not mistaken, you have a list of some famous comets that we may have heard of?
Yes, that's right, Spence. So let's take a look at the most famous one that you mentioned. That would be Halley's Comet. It was discovered by Edmund Halley in 1682. It was actually seen before that several times, but he realized it was a comet that was returning, and he predicted that it would appear again in 1757. That is probably the most famous famous comet out there. Comets were historically omens of bad news or bad things to come. And in fact, there's a well-known tapestry that dates back from 1066, which depicts the Norman conquest of England, and in that tapestry is Halley's Comet. When they saw that comet in the sky, they realized something bad was going to happen, and sure enough, England got invaded. So that was an example of one of those bad omens. But it's not just in ancient times. During the 1900s, the early 1900s, our 20th century, there was a huge panic here in the United States and around the world because just a couple of years earlier, scientists using what's called a spectrometer had detected cyanogen in Halley's Comet, in the tail of Halley's Comet, and people were afraid that as the Earth passed through the tail of Halley's Comet, they were going to be poisoned by cyanide. There was a huge panic, and the scientists did the best they could to calm the people down and explain that the concentration in the tail is so small that it wouldn't kill anybody at all. So even in modern times, comets have caused panic and been omens of bad things.
Richard, if I remember right, wasn't Halley's Comet associated with Mark Twain in some way?
You're right, it was, Spence. Interestingly, the year that Samuel Clemens was born, Halley's Comet was visible in the sky. And he even predicted that when it comes back in 76 years, he probably would be going out with it as well. And in fact, his prediction was very accurate. He died 76 years later. So there's another bad omen, if you would, that was recognized by Mark Twain himself.
So Richard, I remember seeing pictures of a comet that slammed into the planet Jupiter. Can you tell us something about that?
Sure thing. So that's my my next comet here on the list, Shoemaker-Levy 9. That was in 1992, and many of us were glued to the TV set watching this comet slam into the atmosphere of Jupiter. In fact, before it did hit Jupiter, it broke up into 21 pieces, and the largest piece was 2 miles across. It was huge, and each had a tail, and we got to watch over a period of hours and days each of these pieces slam into the planet, and they left a bruise in the planet's atmosphere. You can see in the upper left corner of the slide, you see a picture of Jupiter, and those bruises that these pieces made, that the largest bruise was actually larger than the planet Earth itself, and it produced an explosion equivalent to 6 million megatons of TNT. That's about 33,000 times more powerful than the bomb that was dropped on Hiroshima.
Very interesting. So I noticed that you've, as you're naming comets, there's the Shoemaker-Levy. We talked about Halley's Comet. Is it true that a lot of comets are named after the discoverers?
In fact, that's historically accurate. There's been many individuals who have discovered comets. I'm going to list a few of them. A few more comets here. Hyakutake was named after a Japanese amateur astronomer, discovered in 1996. Hale-Bopp was two amateur astronomers, Tom Bopp and Alan Hale were both amateur astronomers. They discovered the comet independently around the same time in 1997, and because they discovered it about the same time, within hours of each other, both of their names appear in the name itself. Hale-Bopp is a beautiful comet to see. Last time it appeared in 1997, it was brighter and more beautiful than even Halleys Comet itself. And then another example is Comet Borrelly. Comet Borrelly was discovered by a French astronomer in 1904, Alphonse Borrelly. It's interesting because we actually sent a spacecraft there. NASA sent Deep Space One to visit that comet in 2001. And here's an actual snapshot that it took as it orbited or passed by the comet. Kind of looks like a strange elongated potato. There's many people who have discovered comets, amateurs as well as professionals. One of the most famous is David Levy of the Levy Shoemaker 9 comet that I mentioned earlier. He was a Canadian amateur astronomer and the author of many books. Gene Shoemaker was an American geologist and is considered the founder of the field of planetary science. And his wife, Carolyn, worked very closely with Gene. And after Gene's passing, both of them worked on a team at Caltech there. And she was the Shoemaker of Levy Shoemaker comet fame. And I mentioned Alan Hale. He was actually a construction worker, manager of a construction site, and an amateur astronomer. There's quite a number of amateurs who spend their mornings or evenings in fact, there's over 1 million asteroids that have been identified and over 3,700 comets, known comets. And the comets all have names, but not all of them were discovered by individuals. In fact, you mentioned near-Earth asteroids and potentially hazardous asteroids. There's many automated surveys, telescopes, both space-based and ground-based, that are regularly scouring the sky looking for objects of this type, in particular near-Earth asteroids and PHAs that you mentioned. They're funded primarily by NASA, but in other countries by other governmental agencies. One of the most well-known and prolific is the Catalina Sky Survey, based in Tucson. That survey has discovered over 11,000 near-Earth asteroids. These are the ones that are relatively close or get relatively close to the Earth. Linear and Pan-STARRS, these are also very prolific surveys, and you'll find their names in the name of comets that they discover also. So the Neowise comet that you mentioned earlier actually has a longer name. I forget what that longer name is, but Neowise is in the name because it was discovered by a NASA orbiting platform, Neowise. That program actually ended a few years back, but it discovered 328 near-Earth objects. So the comets will have either the name of the individual or individuals who discovered it, or it will have the name of the survey that found it as well. So, okay, Spence, I'm an amateur, like many of the people who are online tonight with us. What can we expect to see when we go looking for a comet?
Okay, well, that's a good question, and I feel a little pressured, Richard, by that question, but let me see if I can walk everybody through it. So one of the most important things when you want to determine whether you're going to be able to see something in the sky or not is determined by the magnitude or the brightness of that particular object. So there is a magnitude scale. The magnitude scale measures the brightness of objects. The slightly tricky thing is that the greater the magnitude or the larger the number, the dimmer the object. So if you look at the chart down below, you can see on the far left, there's a very large negative number, and that is the brightness of the sun. I think it's -26. If you move up the scale, objects become dimmer. You get to a full moon, and Venus is still a minus number. It's -4.6. You travel a little further and you get to Polaris, which is a +2. So between Polaris and the naked eye limit is where you can expect to be able to see comets in the sky. So the naked eye limit, I think this was mentioned before, in dark skies under optimum conditions is around 6. So anything that has a larger number than 6, you're not going to be able to see without the aid of some instrumentation. And that's in dark skies. If you're near a city and you have light pollution, or there's a full moon or a partial moon out, you're not going to be able to see an object that has a magnitude of 6. It would be more like 3 or 4. And what I want to say here is if you're trying to determine what you can see and what you're going to need, almost every object, if you look it up online, one of the things associated with it is its magnitude. So if you go online, you want to see a comet and you find out its magnitude is 15, you're not going to be able to see it. If its magnitude is maybe 3 or 4 or 5, then there's a good chance you're going to be able to see it. So you want to collect this information before you go out. So how does that relate to the comets that are visible now? This I just pulled off of a chart recently. This is all from this month, this year. And the first thing you can see is that the brightest comet that's currently in the sky is a 6.6. So there's some hope that you might be able to see that comet with your naked eye under optimum conditions, but I can tell you right now that's probably not going to be the case. So as you go down that column, the numbers get larger, which means that the brightness gets less. And so I noticed one of the questions, Richard, was when are we going to see the next bright comet? That's a very good question. The answer is nobody knows. There isn't one there now, but there's hope. There's hope. So the first comet of 2021 is called Comet Leonard. It was discovered, I think, on January 2nd. It's living between Jupiter and Mars, but it's heading towards our sun. It already that far away from the sun has a tail, and that's a very good news. That tail should grow as it gets warmer, as it approaches the sun. It's going to reach its closest approach to the sun in January of next year. It's going to pass by Earth in December of this year. So we have a whole year. This is a very nice thing to be able to do. We have a whole year to watch this comet as it gets closer to us and closer to the sun. So the answer is we don't know when the next bright one is going to show up, other than Halleys Comet, which will be here in 40 years from now. But this is one you may want to keep an eye on. Within 6 or 7 months, it may be bright enough that you can walk outside and be able to see it, but only time will tell. So if you can't see it with your naked eye, what do you need? The theoretical limit for binoculars is about +8 or +9, again, under optimum conditions. So if you see a comet or any other object that's +8 or +9, you can get to a great spot. You might be able to see it with fairly large binoculars. And then obviously, as they become more dim, you need more light gaining capacity. So if you get in the range of 10, 11, 12, you're going to need a telescope. The 3-inch telescope maybe you'd be able to see a comet or other object at plus 11. When you get down past plus 12, you need at a minimum a 6-inch telescope. And if you're lucky enough to either have or know somebody with a 12-inch telescope, you'll be able to see objects that are even more dim than that. So that's sort of an indication of using the magnitude to give you an idea of what instruments you're going to need to be able to see it and under what conditions. So the first thing I think you may be asking yourself is, okay, there's nothing up there now that I can see, even if I have a large telescope. So Richard, is there something out there that we can do to be able to see these comets as amateurs?
Yes, actually, fortunately there is, Spence. As you mentioned, generally we need a large telescope. And not all of us have very large telescopes. Some of us have, very small telescopes, maybe even binoculars, and they're not going to work for a very dim comet. But fortunately, there are telescopes, large telescopes, that you can actually sign up to control. And one of those sites where you can subscribe to and actually control and acquire images from is slew.com. I have a membership to Slew, and we use it here at Science Heads all the time for viewing objects, particularly when it's cloudy outside. We'll use Slew because their telescopes are elsewhere in the world. They have observatories in the Canary Islands and also in Chile at very high altitudes, and some of these telescopes are very large, upwards of 20 inches in size. That's pretty big for an amateur-sized telescope. So that's an option that you have if you want to take a look at any of those comets that you listed in your previous slide, Spence. I recommend signing up for a subscription to Slew or one of the other remotely controlled telescope companies, and take a look that way. Now, actually, there are groups there in Slew that hunt for comets, and one of the most famous members is Don Macholtz, who has actually discovered 12 comets to date. There's a group of other amateurs using Slew as well, hunting around for comets. Don will actually use his 11-inch Newtonian telescope to scan the skies. Usually, he says early in the morning, and then he'll use Slew to confirm it. And I'll share with you some type of images that you could see with Slew. But there's some other choices as well. You can actually purchase telescopes that have imagers built in, such as the new Unistellar telescopes. They have an imager built in, and there's actually groups of amateurs using these telescopes. I'll share some information about that. And then you can use NASA's telescopes, believe it or not. You can actually download images, recent images from NASA's SOHO telescope, which is observing the sun all the time, as well as other NASA orbiting telescopes, and find comets and image objects using those telescopes also. By the way, Spence, I mentioned Don Macholtz. I just attended a star party yesterday that he hosted there on Slew, and he talked a bit about his process. You know, it took him 3 years to discover his first telescope. That's how dedicated he was. He would use his 11-inch Newtonian, as I mentioned, in the morning, typically in the morning, because the automated surveys are not looking for comets early in the morning or just after sunset, because they don't want to get too close to the sun with their imagers. So for 3 years, about 1,700 hours, he spent looking for comets before he discovered his first one. So it's not a particularly easy task, but God bless him, he discovered 12 of them.
So Richard, you talk about Slew. Let's say I'm an amateur and I want to sign up what actually can I expect to see?
Here's an example of that, Spence. So these are actually 5 images collected by one of those amateur comet hunters on SLU that I mentioned. 5 images taken over a period of a few hours, overlaid. The telescope was pointing at a specific star field. And how did he know he found a comet? Well, we can see the motion of that comet over a period of just a few hours. And that's actually how you can confirm you've got a moving object. It's going to be a comet or something else. Stars aren't going to move. Galaxies aren't going to move. But comets, as you mentioned, can be moving very, very quickly. So if you use SLU or other imaging telescopes to collect images over a period of time, and if they look fuzzy, like the pictures that you showed earlier of Neowise or Hale-Bopp, you found yourself a comet. Now, it's really easy with SLU to schedule telescope time. It doesn't cost very much at all. And you can enter in the coordinates that you want to image, and you could schedule several images over a period of time. How do you know what the coordinates are? Well, there's actually several websites that you can look up the coordinates for any object that's been identified. The Solar System Dynamics website, hosted by the Jet Propulsion Laboratory, allows you to search and find the object. And then if you click on the button in the middle bottom there that says Generate Ephemeris, it'll give you a listing of all of the right ascension and declination values, in other words, the position of that object over the next few days. So all you got to do is plug those values into that SLU screen that I showed you a moment ago, and you can schedule the 20-inch telescope to capture that star field. And if you do that over a period of time, you may discover a comet as well, or you may capture the comet that you're looking for, that you searched for. I mentioned the imaging telescopes that are available now. Now you can add an imager to any telescope, just about. This particular company, Unistellar, actually has the imagers built into the telescope itself, and you don't need a very big telescope. You can see a picture of this fine-looking couple with their Unistellar telescope. That's probably about a 3-inch telescope there. Has a built-in imager, as I mentioned, and this group of about 3,000 interstellar amateurs are working in combination with the SETI Institute, and collectively they're capturing information about asteroids and helping the professional astronomers determine the size and shape of asteroids using their little telescopes that spread around the world. So there's some really cool citizen science opportunities that you can get involved with if you have a telescope, if you have an imager, or if you're not interested in doing citizen science, but you want to capture some really nice images of some of the comets that we've been talking about. Sign up for SLU or one of the other remotely controlled telescope sites, and it's not hard. You can capture some great images even if you don't have a telescope. So, Spence, then in summary, it's all about planning ahead, isn't it?
Absolutely.
Reading news articles. They'll help make you aware of comets which are coming. Every now and then you'll see that on CNN or Fox or USA Today. They'll say, naked eye comet projected to become visible in August or something like that. Well, as you mentioned, the predictions about becoming naked eye are pretty spotty. It's really not a very good science to determine whether it's becoming naked eye or not. But it's always nice to know there's a possibility of one. And then it's a matter of determining where it's going to be located in the sky, what magnitude it's projected to be, so you know what kind of equipment you're going to need. Maybe you need to get out your 8-inch telescope. Maybe you need something bigger, so use a SLU telescope, for example. If you're going to be using your own telescope, it's probably a good idea to go out to a dark sky site. If it's going to be below naked eye, magnitude, then you want as much darkness as possible, and you want to do it on a moonless night for sure. But this can be a lot of fun. Watching in the news, a comet's coming, knowing where it's going to be, what its brightness is going to be. It's like Easter egg hunting for adults. It can be a lot of fun, and if you do it, I invite our guests to send us a picture. Use your cell phone or use the imager for your telescope and send us a picture. We'd love to see it. Just send it to info@scienceheads.org, and we'll post it on our website. We would love to see you applying what knowledge we shared with you tonight. Now I've listed on this slide here some of the websites, or all the websites that we've talked about, and a couple of more. So NASA's got a couple of great websites about asteroids and comets as an introduction and to dive deeper into the topic. I listed the SLU website as well here, and the JPL website, where you can look up those ephemeris of those objects that you want to see with your telescope, or schedule a SLU session for. And if you just want to do it all from your desk and your armchair, here's the website for downloading SOHO images, that the NASA SOHO telescope, which is constantly imaging the sun. There's dozens of or more amateur astronomers who are scouring through those images and have discovered comets, because as they get closer to the sun, they get harder to see. The automated surveys can't find them. The amateur astronomers with telescopes can't see them because they're too close to the sun. But SOHO picks them up, and there's been a lot of comets discovered that way. And then if you're shopping around for a new telescope with a built-in imager, I've listed the Interstellar website for you as well. So plan ahead and have a lot of fun doing it. So Spence, I want to thank you for all this information that you've shared with us. This has been incredible. A lot of detailed information, background information about comets and asteroids. Thank you so much. It's been really a wonderful webinar.
Well, thank you, Richard, and I very much enjoyed it as well.
And I encourage our guests to register for our next star party. Now we're going a little bit off the topic of the typical topic for amateur astronomers, because it's African American History Month in February. So we're going to be focusing on the space program, the NASA space program, particularly African American astronauts and astronomers who have participated in the space program, particularly the Space Shuttle and the International Space Station. That'll be on February 12th at 5 p.m. Here's a link to register that. You're also welcome to go to the scienceheads.org website. If you pull down the locations and programs menu, or the About Us menu, and choose programs and locations, you'll see all of the programs that Science Heads is offering. Not just for adults, also for children. We have book reading circles, and we have programs for schools, and we have a high altitude balloon launch coming up. Who would have thought? On February 20th, we'll be launching a high altitude balloon, our 6th balloon, which will be carrying student designed experiments about a third of the way to space, or we like to generously say the edge of space. So again, thank you for joining us tonight. I hope you had a lot of fun and learned a lot. We certainly did. And I hope that you can join us on February 12th for our next webinar.